Bitcoin is close to becoming worthless.
Let's go. Now, what's the Bitcoin?
Bitcoin's like rat poison.
Yeah. Oh,
The greatest scam in history.
let's get it.
Bitcoin will go to fucking zero.
Yeah.
Alright, you ungovernable misfits. I'm your host, Max. Everybody knows that Bitcoin is useless, worthless, and doomed to fail. But what if everyone's wrong? What if it's the system that is doomed to fail? Join me as I speak to some of the brightest people in the space and slither to the deepest, darkest depths of the Bitcoin rabbit hole. Welcome back to another day of Pleb Minor Month. Today, Jon and Sal talk about why IT and Telecom is the backbone of the Bitcoin network. I really enjoyed listening to this episode. I learned so much from these guys. They went deep down the IT and Telecom rabbit hole, and I think you're going to really enjoy it. Before we start, I just want to say thank you to everyone who's been involved in Pleb Minor Month. If you've submitted an article, jumped on a pod, done a bite-sized Bitcoin, retweeted, sent sats via the Podcasting 2.0 apps, or any other involvement, I just want to say it really has been incredible. It has far exceeded my expectations and I'm really enjoying it so far. Make sure to check out ungovernablemisfits.com. We have all of the articles, podcasts, bite-sized Bitcoin and prizes. There will be prize draws every single day this month, and we have 10 S9s to give away, as well as Foundation devices, passports, fan shrouds and crypto cloaks, and many, many more. So thanks again to all of those guys, and I really hope you enjoy this one. Hey, Sal.
Hey, how are you doing?
I'm doing well. How are you?
I'm all right. It's been a good summer.
Good. Yeah. It's been a weird summer in a way, hasn't it?
Indeed.
The reason that we're having you on Pleb Minor Month, and I think this is kind of an important thing for Bitcoin plebs to understand, is exactly how their nodes and their ASICs, their machines are interconnected with each other. How does the Bitcoin network actually work in a physical way? I had put out a tweet last year kind of describing the telecom industry. Of course, that's what I do. How do we get from point A to point B, whether it be copper or fiber or satellite? And now we even have kind of low orbit satellite stuff, cellular networks, even getting into the 4G, 5G aspect of things. And at the end of that tweet, it was more of a call to action, like, hey, I don't have the answers for you. You know, I'm just kind of a grunt on the ground who builds this kind of stuff. But if you do have answers, if you do have suggestions, you know, reach out. Let's talk. Let's collaborate. That's kind of one of my favorite things. And you were one of the people that reached out to say something. And do you remember that tweet, Sal?
Yeah. I can't remember what event it was that spawned that conversation, but I know we kind of resurrected it when the conflict in Kazakhstan spun up in January, and we discussed again how, you know, a significant portion of the hash rate and, you know, Bitcoin users that might live in Kazakhstan were kind of knocked off the internet because of the political situation over there.
Mm-hmm. And it really kind of pointed out just exactly what we were talking about. I do believe the initial inspiration for the tweet was a lot of people saying, well, I can be my own ISP. And I think I wanted to tell people there's a lot more once you get outside of the walls of your home or your business or your apartment building or even your business complex. Once you get outside of those walls, it's a very complicated machine. And I know the physical part of it, and I can tell you that's complicated, and it gets even more complicated beyond that. So I think that was a little bit of part of it, is people not quite understanding what an ISP is, that it's a little bit more than a distributed LAN.
Absolutely. And I think we'll get into some of that here with what we're going to talk about today.
So you and I got together in kind of a little chat group, and we were going to at least attempt to collaborate and coordinate with one another what suggestions we could put out there on the internet to solve the problem. And I think it kind of gets frustrating being disparate as we are and not able to physically speak to each other and collaborate in that way. And that group kind of didn't really go too far. And I don't think we came up with anything actionable. But maybe in this exchange between the two of us, we can educate everybody out there, and maybe they can kind of join the discussion and help us solve the problem, or at least make the Bitcoin network more durable.
Absolutely.
So Sal, do you kind of want to go over I can go over the history of how we got to this point, and kind of the first interconnected thing we've done with each other as human beings to communicate over distance would be something like light signaling, beacon fires, flags, and then when we kind of got into the industrial age, we have the AT&T is American Telegraph, right? American Telegraph and something, but the first T is telegraph. So that kind of started with the railroads and extending on, interconnecting different stations and through copper. And of course, you'd break the electrical connection between two ends, and then you have Morse code. We go beyond that. We got the first transatlantic cable. I think they tried that a couple times to get a piece of copper from one end of the pond to the other, as they say. But they finally got that accomplished. And then we have Alexander Graham Bell and inventing the telephone and how we can speak to each other. And that really kind of set things off to connect the world through copper. So once you did that, now you have central offices that are going to be the point to which you connect one subscriber to another. And in those central offices, you would have somebody manning a switchboard that they would call to the central office. The operator would be informed that somebody had gone off hook. The operator would physically talk to you and, where can I connect you? Let me go to Orange 9600. That's before the long distance, the area codes and exchanges came into existence. And they'd physically patch you to another copper wire that got to the other user, get to the internet era. And now we're able to transmit data over those same lines through fax machines, I believe, kind of were one of the first things. And then we get into the inception of the internet and DARPA. And maybe you can kind of take things from there, Sal.
Yeah, so I like your reference to the switchboards first because, it's like literally taking a cord out of one plug on the wall and putting it into another plug on the wall to make that connection happen. From a historical perspective, the DARPA, sponsored the research that was done to create what is today the internet. And for a long time, the government, the federal government, was responsible for basically in the telephone equivalent, assigning telephone numbers to whoever wanted them. Today, that falls under a private nonprofit organization called the Internet Corporation for Assigned Names and Numbers, or ICANN. And so if you want to be an ISP, you have to have IP addresses. And so you have to also have some identifying numbers to tell other ISPs who you are and what numbers you're serving to the internet. And so you have to go to these organizations and request or purchase or register. There's a couple of different processes there. A large number of IP addresses for you to use for your ISP purposes. Globally, just about each continent, not exactly each continent, but globally, there are 5 regional internet registries, and the one in the United States is called ARIN, ARIN, and so this is basically, in the telephone analog, this is the idea of how we all have an individual telephone number, and in Atlanta, there's one area code. In New York, there's another area code, so that nobody in those 2 locations ends up having the same telephone number.
Right, and it even kind of boils down beyond that. The area code got you to a certain region, and then you boiled down to the exchange. That's the 3 numbers in the middle. And the exchange corresponded with the central office that was serving that particular area. So say you lived in New York, and don't quote me on this, I don't know all the exchanges within the New York area, but you lived in Brooklyn or something like that. And so your New York would be your area code, and then your exchange would be whatever Bell Telephone AT&T central office fed that. So if it was like 222, then that was that particular central office that fed that. And then you would narrow it down to your particular line or your particular loop out of that exchange. And then that would be the last four digits.
Correct. That's how I remember it. I think over time, a lot of those central offices have consolidated. So like you might have, and you would probably know better than I, but you might have, especially in large cities, you might have one central office that really has, 10 or 20 or 100 different exchanges hosted at it.
Yeah, and you'll definitely have larger central offices in larger areas. But as far as the old telco goes, that was everything in that central office was physically connected to a subscriber, and then all of those central offices in that way, and we'll kind of go in further on when we get to the internet. They were interconnected to each other through toll cables, and that would be under like the jurisdiction of a larger organization. So you had your regional bells, and then all the toll cables in between were controlled by AT&T. As far as in the United States, Canada had a similar system, and I assume UK and other European countries had similar systems. So when we're coming up with the internet, the way to be interconnected between those regions was to have these nodes, and so that's kind of like a tiered system where you have your subscriber, then you have your local exchange and your local central office, and then you'd have like another tier beyond that. That is the toll cable or the trunking cable, as we used to call it.
Yes, and with respect to the internet, those it's generally divided into three tiers. So you have tier one internet service providers that are out there laying the physical connectivity to provide the highest speed, highest bandwidth backbone layers of the internet, and these groups make relationships with each other. They typically have business, direct connected business on multiple continents. So you were talking earlier about transatlantic cabling. So you might have a tier one internet provider that has a transatlantic cable and between Europe and North America, and a trans-Pacific cable between North America and Asia. And so that would, kind of qualify that particular business as a tier one internet provider. And typically between their peers, they don't charge fees or tolls to transmit data between themselves. And this is kind of how, let's say, the core of the internet is put together. Where they do make their money and provide, the ability to produce that infrastructure is by selling access to it to the next tier down the chain. And so the tier two providers are the national internet service providers that might, multi-state, East Coast, West Coast, maybe. They have connectivity across country, or at least presence in places across the country. And for the most part, this tier doesn't actually serve people like us with internet. That is reserved down to the third tier, which is your local telco carrier, might be an ISP. So there's a couple of those around where I live. There's TV cable providers that do that. And while those are big companies, their ISP presence is kind of smaller from a regional perspective. So I'm drawing a blank on a company name, but Time Warner is a different company now, but they used to have be an ISP that had a big presence, let's say in Atlanta, and a big presence all up and down the East Coast.
Yeah, I believe the Time Warner got with Cox, and I think they became something else. Time Warner and Cox. Cox was more like Rhode Island, Vermont, New Hampshire, that kind of area as far as cable providers. I think most people would be familiar with their local ISP, more to say like AT&T or Bell South, Pac Bell, 9X was in New York, GTE. Those would have been your legacy Bell telephone or Ma Bell system. But to go back to tier 2 and the interconnectedness in there was a large organization called UUNet, and it's part of the original internet backbone on the East Coast ran on UUNet fiber. And UUNet's power came in the fact that they had signed all of the old telegraph right-of-way agreements. So they would run fiber wherever there was a railroad. And in those old systems, you would only be able to run fiber so long, like maybe 30, 45 miles, something like that, before the signal needed to be broken down because of dispersion and other fiber issues and built back up and sent down the chain. So the original internet, those backbones internet would be provided by people that could get those kind of right of ways to go long distances. And that's kind of one of the inhibitions and why not just anybody can get into the tier 2 game. You have to take fiber an extremely long distance. Now you can do something else. You can do like a line of sight microwave relay, but that has its own problems in itself, as you have to have two antennas that can see each other in a long distance. So the vast majority of that kind of traffic is going to go over fiber. And then to kind of break down tier 3 to people a little bit, we're going to go back to that comparison or that history lesson of how the old telephone exchanges worked and the telephone central offices. Well, now your local ISP and even your cable provider ISP have to physically run a cable from their offices to your home. Let's take the traditional telephone route, and with the inception of fiber to the home product, what you're going to do is you're going to come out of a central office through the underground. You're not going to see a lot of telephone poles and cables going up poles. Those kind of runs are done underground because when you're starting out from the central office, you have every connection there within that central office's footprint in that cable. So you're coming off at really large cables through the underground, through manhole runs. And then when they're going to get out to more areas where they're able to serve people in residential or small business areas, they're going to pop back up on the poles and they're going to go aerial. If you're in a new plan, they might stay underground, but not so much in underground large duct banks and conduits and stuff, manhole runs. It'll just be direct bury, and they'll be able to access that cable there. And then once they get to the subscriber, they're going to break down that fiber signal and have a device in your home that's able to serve as the modem, and then that's going to go to your router. Now, the cable company does something a little bit different. They're going to run fiber out from their central office to a node for the most part. It's going to be, you're going to look in your neighborhood and see a box that's on a telephone pole, and it's going to be powered. So whenever your power goes out, a lot of times those fiber to the node products don't work anymore. And then they distribute from that node. They'll demux that fiber signal and send it out over coax cable. From coax cable, it'll be a large aluminum the outside diameter of the cable is aluminum. And then you have an insulator, and then you have a center conductor. That's the whole coaxial. That's what that means. And they'll go out to a tap. They'll tap off of that coaxial cable, and they'll run the cable into your home and break it down with a modem and go from there.
Yep, that's been my experience. I have a cable modem in the basement of my home. I do see in some of the newer areas, especially with cable, you do find now some of the nodes or distribution points in neighborhoods are a little more robust than just as you described, like a box on a telephone pole. I know the one that serves me is they have a backup generator outside. It's a small brick building, and there's always the ISP branded trucks in the parking lot. I drive by it about every day on the way to and from my Fiat job. So
yeah, the traditional telco central offices have a huge battery plant within them, and additionally large generators and whatnot. And that's because the tradition. I know everybody listening to this doesn't want to hear so much about old telephone stuff, but I have a lot of history in my brain about it, and I got to get it out to somebody. There's a battery plant in there, and that provided the voltage that went on your telephone lines, the negative 48 volts that went on the phone lines. So there is also that kind of power backup there that can be pulled off of the battery plant. If you are in an area where we have not we, if there's a fiber to the home product for you, that is all passive from the central office to your home. That's all just passive fiber. Once it gets to a certain point, that signal gets split down to get distributed amongst other customers. But that splitter is also passive. It's just kind of a prism that just breaks the light apart. And then by the time it gets to your home, you're going to need a modem, or it's called an optical network terminal to feed that out kind of like a modem to your router. So if you have a generator there, you have some kind of battery backup for that, you're still in business.
So that's kind of fascinating to me. Because I don't know a lot about how those physical layers at a distance from my home or my office work. So I know that I have some colored wave fiber stuff in my office. I don't really understand how it works, but I know that it's very expensive, and we get very good service out of it. So it's interesting to me that kind of stuff is coming out to residential.
It is interesting also because of how exclusive fiber used to be, and fiber was in that tier 2 system, and that's the only use that it had. And you'd be surprised, some of these large circuits, these large tier 2 circuits, are still running on fiber that was deployed 40 years ago. It still works. And as far as that tier 3 goes, let's not exclude the fact that people have satellites in their homes, satellite dishes, whether it's HughesNet or I think DirecTV provide some kind of bandwidth to people, but I think HughesNet is kind of the popular one. Cellular networks run the same way. You can almost think of a cell tower as like that optical network terminal that's in your home, like the cable modem that you have downstairs in your basement. Those satellite providers they're ordering bandwidth from the local ISP, or they're ordering bandwidth from the cable company, somebody that's going to provide them that tier 3 bandwidth. Cell providers are ordering that same bandwidth. It just goes to a cell site and gets broken down into a radio signal. 5G works the same way. 5G deployment is usually the large cell towers that you see. That's a macro cell tower. The 5G units are a micro cell tower, but same thing. Fiber is ran to those poles. You're tapping off of that. You're running it into a multiplexer or demultiplexer, and it's getting transmit out on radio signal.
Oh, that sounds awesome. Totally geeking out.
I think maybe we could even, once we kind of go into our next topic, try to describe how Starlink is a fusion of all of those things. It's really kind of the culmination of all the technology. Not that I'm a huge Starlink believer or say that it's going to be the panacea to solve all of the world's bandwidth problems. I think they say like only half of the world is actually internet's ran to it, especially rural areas or poor areas of the world. And Starlink is going to be a good solution, but we can get to that later.
Yeah. I honestly don't really know much about how Starlink works. So that'll kind of be new to me, but as we had talked on Telegram a little bit, I look at it as a kind of, from my endpoint as kind of a network systems guy, I just look at it as another layer 1.
Yeah.
And how the sausage is made is a little above my pay grade kind of thing. So
I agree. But if we get to the point where we can't see the stars because there's so many Starlink satellites, or even what's Amazon doing? Yeah. Kuiper, I think it's called. And then of course the Chinese, who knows what they're throwing up into space. Right. It'll be an interesting next 10 years in kind of the telecom industry to see how that develops.
Sure.
But and here we're kind of talking about Amazon and Tesla and Elon Musk, and it just goes to show that this isn't just one centrally controlled thing. This isn't just one centrally controlled entity. It's the largest engineering project in humanity, right?
Sure. Yep. That's got to be the best way to look at it. When you start to sum up the miles of cable, the miles of, and when I say cable, I mean like copper cable, the miles of fiber cable, the miles of trucks and boats and space vehicles have traveled to, create the physical layer. And even when we're using wireless, let's still consider that the physical layer.
Yeah.
It's fairly easy it's fairly hard to comprehend how big those numbers are, but it is fairly easy to say that this is the building and maintenance of the internet is pretty much the most massive human engineering project ever undertaken.
Bitcoin kind of emulates it in a way. Everybody's doing their own thing individually. You're building your node at home. You're setting up your mining rigs at home. You're running your Cat5 within your home, and then once you get out of your home, you're connecting to people that have done the same thing, and you kind of multiply that by a billion, and then you have kind of the telecom IT industry. And you were saying it's a lot of work to deploy these things from one place to another. I'll often go into rural communities that don't have good bandwidth. Really, Sal, it would blow your mind if you knew how many people are still on DSL that still can barely eke out, 1.5 meg, or the amount of rural businesses that are still on T1s. It's really stunning. And from my vantage point, it's kind of upsetting because I wish I could just provide everybody with all of this bandwidth. And people will say to me, why don't y'all put a cell tower here? And I said, well, I'd like to, but the cell towers aren't owned by the local ISP. That's going to be owned by somebody else. So say for Crown Castle, for instance, they're the ones that own the cell tower properties. And then AT&T or Verizon or whatever cellular provider, they're the ones that come and order the circuit that's going to go up the tower and into an antenna array, an alpha, beta, gamma antenna array. So it isn't that your local ISP can just pop up cell towers all over the place. You have to run miles and miles of fiber to get to that cell tower. And that's going to go through a lot of different jurisdictions. It's going to go through a lot of different mediums. Like I said, you're coming out in the underground, and then you're going aerial, or you're going to go direct bury again. You have all kinds of right-of-way issues that you have to deal with. You have all kinds of state and locality issues that you have to deal with. People want to shut you down because you're digging something on the side of the road. So there's a lot of moving parts in order to make all those things happen. And besides that, that's just the outside plant perspective. You've got a lot of really, genius engineers that are designing these networks and ordering the equipment that's going to go at the cell tower location, that's going to go in the central office. People that program these networks and program these circuits. There's really a lot of moving parts to all this kind of stuff.
Yes, and that's that kind of goes to in my world where I run a couple of routers that support peering with ISPs and serving our public IP address space out to the internet, and so that the rest of the internet can find my resources. And it's for me, it's very much a situation where I follow the one is none and two is one kind of thinking, because the internet, as grand as it is often unreliable. And so I have two ISPs because I don't want, my company's, not my company, but my employer's data and services to be offline, while an ISP or their tier 2 ISP has some problem and causes my traffic to be interrupted. And, for people that are outside of large metropolitan areas, the idea of having unreliable internet seems pretty far out there these days, I think. But like you said, people in rural areas are often still
they're quite used to it.
Yeah. For example, I went to the Smoky Mountains for spring break this year, and in
Party,
Tennessee.
Yeah. Did you go to Dollywood?
No, we always just go to Gatlinburg and hike in the park and stuff. We're kind of outdoorsy people.
That's better than the tourist trap that Gatlinburg can be.
But I happen to notice that after having been away for 7 or so years, there's a whole bunch of new cell towers sticking up out of the mountains around Gatlinburg that weren't there the last time I went there. And it, on the one hand, it's great because I can get cell coverage, and on the other hand, it's not great because you have all these really tall cell towers sticking up out of the mountains and kind of ruining the view. So I assume people of, everywhere, just like they would with trying to put up windmills and things like that, might say,
not in my backyard.
Right. Not here. Do it somewhere else. So it is an interesting challenge, and it will be very interesting to see if the satellite-based internet like Starlink and HughesNet that you mentioned can cross that bridge without creating too many problems, like space junk problems and whatever else.
I've even heard tell, and I don't know how much FUD this is, that they could kind of obfuscate your view of the stars. That some stars you see might actually be Starlink satellites, and instead of seeing a star, just a reflection from the sun. But you talked about IP addresses, and everything does need to be addressable. How do you get from point? How do you know? Just like that telephone operator, you would go off hook, but back in the day, you actually used to have to crank a generator that sent voltage down the line and flipped over a little indicator there in the central office, and the operator would see that, and she'd pick up on there, but she would have to know where she's going to route you to. So it essentially is that what IP addresses are?
Yes. So IP addresses are like phone numbers. I mean, that's probably one of the best analogies we could come up with, given what we've already talked about today. And the interesting thing is, just like with phone numbers, so you mentioned your local exchange might have a 3-digit, the first 3 digits of a 7-digit phone number. And for those of us who
we're old enough to know we're also old enough to know that you didn't used to have to dial the area code.
Well, that's true too. Yes. But for those of us who are good enough with math, the last 4 digits, you think about, how many combinations can 4 0 through 9 digits create? And it's basically 10,000. So, for every 3-digit exchange number, you could only serve 10,000 customers. And so in a similar way, we have problems like that with the internet. So IP addresses that most of us are very familiar with looking at are 4 blocks of 3 digits. Those digits range from 0 to 255. And so that creates a total of about 4.2 billion IP addresses if you extrapolate all those different combinations out. Only about 3.7 billion of those are useful. And, well, I shouldn't say useful.
Why is that, Sal?
Well, like your home network, right?
192.168.0.
Yep,
0 through 255.
Exactly that.
Yeah.
That network, well, everybody that has a home network pretty much has that same IP address for their home network. But on the internet, there's a whole class of roughly about 600 million different IP addresses that are reserved and are not routable on the internet. And they're used for things like the home networks. The catch with these IP, what's called IP version 4 that we've been talking about, is it's almost entirely used up. So we have pretty much reached the maximum capacity of devices on the internet for IPv4. So if you were to start a new ISP today as a business and try to get a block of version 4 IP addresses, it would be terribly difficult.
Now, was the really the push for the next iteration of IP addresses because of Internet of Things devices coming online, and now you have all these other addressable items that are people couldn't really fathom 10, 15 years ago?
Yes, I think so. But IPv6, the next generation, has been in the works since the late 90s. So the really smart wizards who were running
they all got the shit scared out of them from Y2K, so they said we better address this
yes,
this IP address situation.
I think they could see that the numerics of, the combinatorics or the numerics of it was, going to be a little short of what would be sufficient for the world. So, like all good engineers, they over designed the next generation system. So, if you were to look at an IPv6 address, it's terribly complicated to understand by comparison. It uses a bunch of blocks of letters and numbers, very similar to the old IP address system does. Those are all hexadecimal, so it's 0 through 9 and A through F, the letters A through F.
Okay, so that's why there's a limitation there. It doesn't go beyond F just because it's hexadecimal.
Yes. Yeah.
Okay.
So hexadecimal is like, we count in tens, so 0 to 9 are the digits we use. Hexadecimal is just adding those letters to represent additional digits.
Understood.
Yeah. So if we think about binary is all zeros and ones. So that's, if you had 2 fingers, you could count binary very well because you'd be used to it.
I have more than 2, but yeah.
But we have 10 fingers, and our numeric system is based on 10 digits. So
get out of here.
It looks very confusing to look at a hexadecimal number, but the result is that it creates an inconceivably large number of possible addresses. And I'm not going to take credit for coming up with this analogy, but
I'll give you credit.
No, it's I pulled it off the internet. It's somebody from way back when, and I
should trust the
cite
internet
them, but I don't have their webpage in front of me. But the number calculates out to about 3.4 times 10 to the 38th power. So that's like adding 38 zeros onto the end of 34 and trying to give that some assignment of, some verbal assignment. But if you were to assume, so here's the description. If you were to assume that every sun in the universe had 10 planets, and that every galaxy, like the Milky Way, has 100 billion suns, and the universe is made up of 100 billion galaxies, so you have 10 times 100 billion times 100 billion, each planet would still have enough for 3.4 quadrillion IPv6 addresses.
All right. So if my refrigerator, my stove, all these stupid things that I have in my house, we're all good.
Yeah,
they can all have an IP address.
Yeah, we should be.
Okay.
So
I'm gonna have to try to figure out something, this galaxy star thing, because I did a bite-sized Bitcoin a while ago where I actually read out the number of hashes per second that the network had, and I think at the time it was like 230 exahash. It was really high. I'm glad we're more around 200 now. And I was kind of saying it out loud. I'm like, this sounds stupid. Who's gonna be able to visualize this as I'm describing it on a podcast? So maybe I'll have to break that back down again with stars and planets, and obviously that's something people can conceptualize.
Yeah. So Bitcoiners. So real quick, Bitcoiners are familiar with terahashes and petahashes. So terahashes are a trillion hashes per second. So much like the U.S. federal budget, we spend trillions of dollars every year. So that's a new common term in our vernacular, right? So a quadrillion is 1,000 trillions. So a petahash is 1,000 terahashes. So a quadrillion is in the same order of magnitude as a petahash.
Understood. That's good.
Helps.
That does help. I've always thought, kind of when I have these conversations with people, everybody's got all these tattoos nowadays. I'm actually one of the few people that I know that doesn't have a tattoo. But why don't you tattoo something useful on yourself, like this whole breakdown of quadrillion and trillion? You can use it in conversation instead of somebody gets like an outline of a dinosaur.
Yeah. The way I look at it, though, it would be it would be outdated in a year.
with the national debt going up, so we're gonna be talking in quadrillions in no time. Don't
Right.
bother with this trillion bullshit.
Right.
So we're 40 minutes into the conversation here, and I think anybody that's listening kind of gets an idea, like, wow, this is a lot more complex than I thought it was. And each subject we're kind of going through, I think there's just so many adversarial types in this world that can break that chain that we have amongst each other, that can somehow interfere the communication between our nodes, they interfere the communication between, our machines and our mining pools and so on and so forth. I think we as a community, whatever you want to call it, we've got a lot of work to do to try to figure this stuff out and see how we can't maneuver through it. But it's kind of like, all right, we have all these different these physical layers. You can describe the ISP system and the tier 1 and 3. It's like, but what actually like makes up the internet?
Well, I guess we kind of have to say, well, what part of the internet are you talking about?
Mm-hmm.
What part of the internet do you want to know what makes it up? Because
sure, I mean that's like a childlike question, isn't it? Like,
yeah, it is.
Well, where do I start, kid?
Yeah, we kind of have gone through this, the explanation of this supermassive network that the world has created,
mm-hmm.
and we still have trouble defining what it is, I guess. And we spent a lot of time talking about the wiring and the physical connectivity
mm-hmm.
part.
But those are physical concepts that we can convey to people.
Yeah,
and I think you have kind of a really good way of describing what these non-physical concepts that make up the internet are.
Okay, so the next the way to look at this is very much like we look at Bitcoin with Lightning. So Lightning is a layer
mm-hmm.
that sits on top of Bitcoin. Liquid is a layer that sits on top of Bitcoin. The internet, the building blocks of the internet are the same way. So we talked about all the physical connectivity, but how do we actually push a piece of data or a communication message from one place to another?
Mm-hmm.
And so IP addresses are a part of that, but it's not the only part. Imagine being on a teleconference with 10 billion different people. I know there's more than 10. I know there's more than there's less than 10 billion people on the planet, but if we had 10 billion people on the same conference call and everybody was talking at once, nothing would ever get communicated. So we have to have
mm-hmm.
protocols, and we have to have some control over how data and how communication happens. And so very much like the telecom example, where we used to have an operator that would unplug a cable from one port and plug it into another port to make a connection between two people who wanted to communicate.
Mm-hmm.
We have on the internet, we have layers to the internet. And so at the physical layer, we have all this physical wiring. And at the next layer above that, we have this concept of switching happening, and switching and routing. Let's say we'll kind of put those together. Going back to the beginning, those organizations that kind of govern how the internet works assign identification numbers to people who want to be a router on the internet.
Okay.
And that can say, oh, this IP address is over here in Colorado, and this other IP address is over here in the UK. And so if I have a customer who wants to send data to that IP address in Colorado, I have to go out this physical path to the west. And if if customer has data they want to go over to the UK, they have to go out this physical path to the east. And then on top of that, so we have the next layer, which is called the transport layer.
Mm-hmm.
It basically contains little pieces of data that get added on to the customer's communication that do things like differentiate between a web page, the way a web page communicates with a browser, or the way a Slack message communicates with a Slack client across Telegram, whatever, Bitcoin. All of those are different protocols that happen at the transport and application layer.
Now, just to give a little bit of background on that, and a lot of times, so we communicate with each other, and let's just take a voice circuit. I talk into this mic, it gets broken down into bits and bytes. It gets additional information put on top of it to say, hey, this is where you need to go. In some types of transportation medium, back when things were more timed and you had to have the timing sources on either end. It used to be called Lorraine C. It was like a radio signal that went out across the world, and everybody got their timing sources off that. And then the GPS and the geosynchronous movement, excuse me, timing came in. But they would also put pointer bits on that communication. So the timing sources on either end could say, hey, this was supposed to be here. Is this information here? Yes. And then it would continue to transmit the data along. So in that same way, on that transport layer, there's lots of information in there besides the data that you're transmitting and the data that you're receiving. So, and let me ask you a question as far as that transport layer goes. Is this one of the choke points in Bitcoin where you can have devices, sniffers, I don't know what you'd call them, that's more kind of your world, that can see, hey, I'm seeing Bitcoin type information being transmit from point A to point B. Let me intercept that. Let me manipulate that. Let me not route that. Is that possible?
I would say that that's possible at if you had if you were a customer to an ISP who was hostile to Bitcoin. That's entirely possible. This kind of goes out. This kind of could be expanded out to the discussion of what the more political discussion about what's called net neutrality, and that's kind of the idea that as a internet service provider, you have to just pass the traffic that's sent to you by your customers to wherever its destination is going, regardless of whether you like where that's going or you like what that traffic is doing. A really kind of prime example of this kind of thing is suppose that let's go back to the Time Warner concept of I know they don't exist anymore, but in the early days of Netflix, Time Warner is a television cable company. They give you television. You get a set-top box and you get all these channels. They also are a television content producer because TNT was a Time Warner network, and so on and so forth. So suppose as an ISP, Time Warner decided that Netflix just didn't need to exist on the internet because that takes business away from Time Warner. So all of Time Warner's ISP customers might not be able to reach, to stream Netflix because Time Warner just would decide, oh, those protocols, those IP addresses on the internet, we're just going to pretend like they don't exist and we're not going to support them. And of course, that didn't happen with Time Warner specifically. It didn't happen. So I'm not trying to throw them under the bus.
You're pointing them out, but to be fair, they were all doing it. All of the large ISPs were not interested in the whole net neutrality because there is a limited amount of bandwidth, and you even break it down to the customer level. So let's take the cable provider and let's take the cell provider. There's usually a limited amount of bandwidth that they can distribute out like a sprinkler, and that protocol is called DOCSIS for the cable companies. That sprinkler gets a little bit better at divvying out bandwidth amongst the customers. So if you go from like DOCSIS 3.0 to DOCSIS 4.0, that sprinkler gets a little bit more efficient. But a lot of cable customers will notice that when they get home, their internet speeds slow down. And that's because that DOCSIS protocol is only capable of distributing that bandwidth out so quickly to make sure that nobody notices. That's essentially what they're doing, is just, if I can divvy this out quick enough, no one's going to notice the fact that I'm sharing all their bandwidth. And then so when all the streaming services came out, not only are they now directly competing with Comcast and NBC Universal and Time Warner and stuff like that for their content, but now the customers are getting slowed down from things that might be more vital. So a lot of the ISPs wanted the ability to route that traffic how they saw fit, therefore making that decision. And then we can kind of have that argument between each other, or the ISPs and the people who were, net neutrality maximalists can have that discussion. But that's kind of like a business decision we could be dealing with when we get to they fight us phase, where it's not a business decision, but it's a political decision to find out and route the enemies of the global fascists.
Absolutely. I guess for me, that's one of the biggest challenges, I think, to the sort of hostile hyper-Bitcoinization approach.
Mm-hmm.
Where Bitcoin, we get to this point of hyper-Bitcoinization, and it's not a very friendly path. That's what I mean by hostile.
Mm-hmm.
Let's face it, it's a revolutionary thing. So
it is.
Revolution is typically not a very peaceful word. But, what happens to these internet service providers? What happens to our ability to run the Bitcoin protocol, to run our miners and connect to pools and process Bitcoin transactions and such in that kind of environment where the state, federal or state or local, whatever, and the businesses around them become hostile to Bitcoin? We know that goes on in China today, and some other countries are hostile to Bitcoin, and yet Bitcoin still survives. The question is, how difficult is it going to get? And what kind of impacts is that going to have on those of us who are not used to living under that environment? And I don't know how to fix that. I mean, I think about that kind of stuff a lot, but I don't have ideas about how to fix that, except, following the 2 is 1 and 1 is none concept that, hey, I'm going to try to have a relationship with an ISP that I don't think will be, that will be able to serve as my backup, or that might be politically independent, or, because the people that control the lines and the people that control the routing, it can turn those things off. I mean, they may not, there's another aspect to it too, which is a quality of service concept, which is that, and mobile carriers used to do this quite a bit to prevent people from streaming media on their phones. But they would just tune those protocols down to, 10 bits a second or something like that, instead of just leaving it open like they do the web and text messaging and push messages and all that kind of stuff.
And I think that's something that I kind of tried to reach out to people, and on Twitter on occasion. If you're from North Korea, or if you're from some country that has outwardly tyrannical, despotic leadership, I have to imagine you've communicated with other people over long distances. How did you do it? And if anybody's listening to this podcast as part of Pleb Miner Month, do we have any rogue plebs out there in North Korea who are mining? And how do you do it? How do you communicate with the outside network? Because you can do a lot of things over radio. Cell phones are a great example of that. They're radio signals, but the radio that's available for us to transmit from our home, like the FCC allowed bandwidth, your frequency bandwidth, you're not going to transmit heavy amounts of data distributed to lots of different people. So if anybody's listening to this and you know how to communicate pirate radio style, kind of let us know, because that can be effective not only for the Bitcoin network, but as part of the people that I associate with, and that's of course the Mesh HODL guys. That's something that we're deeply interested in, is because we're quite distributed and disparate, and people in South America and Europe and South Africa and Australia and the United States, that if some way our communication is interfered with, we'd like to be able to communicate with each other, whether it's over shortwave radio or something like that. But how do we take those concepts of kind of pirate radio and apply them to the Bitcoin network. It's a problem that I'd like to solve, or at least to have additional context on.
Yeah, and that's a great topic because I'm not a ham operator, but I know that the ability to push data through some of those kind of civilian radio channels is very limited.
Yeah.
So, if we did have to live under that kind of condition and we were able to reproduce some type of internet connectivity that way, we would really have to prioritize how we want to use that. We know that mining doesn't take up a lot of bandwidth, but it does kind of need reliable, timely network access to be able to produce hashes that will be competing for a particular, group of blocking a particular group of transactions. So if your network is too slow, or it's too, and when I say slow, I mean latent, like it takes too long for you to communicate with the pool and the Bitcoin network to try to solve that puzzle. You could do a lot of work to create a hash, and then you submit it, and it's taken so long, you find that block's already solved, and you're too late. So that kind of scenario is almost like a doomsday scenario for Bitcoin in at least in a local regional scenario. So that you're right on spot on there, and I'm right there with you on wondering how that kind of a problem ends up being solved.
Now, I have to imagine there's a lot of people listening to this and saying, well, what about that Blockstream satellite thing? Can we put that all on our roofs and communicate with the Bitcoin network that way? I don't know. I haven't, dove deeply into it, but I have to imagine that they just lease space, off of another satellite. That I'm not sure that they've launched their own satellites into space to be able to do that. Do you know much about that particular technology, Sal?
I don't. I guess I don't, other than what's kind of on their on Blockstream's website. My understanding is it's the satellite side of it's one way; it's receive only, versus a Starlink or a HughesNet, which I believe work a little bit differently. There's a transmit side as well as a receive side.
Sure.
So I think for Blockstream, you would still need some type of access to the internet through a more traditional means to be able to communicate with the Bitcoin network for your blocks. I have read about people who have bought the kits and have hooked them up, but I have not gotten deep into that. So I'll let that for some other expert. Maybe we can find for next year.
That'd be great. By the way, the next pleb mining month is not going to be in the summertime. This has been a big undertaking, I think, especially for Max, to try to get all these pods recorded in August to release in September. So just to take a time out, kudos to Max for all of the recording. I think he recorded 5 podcasts in one day, and then he has the constant editing because he's a freaking OCD psychopath about the audio quality of the podcast. So hopefully we haven't recorded a lot of blips and bleeps and pauses and breaths in this to make his editing a little bit better. But yeah, maybe we can make that part of the next pleb mining month venture is to talk a little bit about Blockstream and have them on. So if anybody Blockstream reps are listening, please reach out to us so we can kind of get a better understanding of the service that you provide. But Sal, we were I took us off on a rabbit hole, and I kind of apologize for that. But we were kind of talking about the TCP/IP model of the internet layers, and I think we got stuck in the transport layer. Can you kind of talk about the application layer a little bit?
Yeah. So the application layer is where most of the things that people like us that sit in front of a computer and work with a web browser or SSH or some other tool interact with. I guess that's the best way to put it. The application layer is going to have all of the data that is, for instance, for this podcast, it's going to have all the chunks of audio data. Okay. And when it comes to how networks work, the application is going to format that data and chop it up into smaller blocks, and those blocks are going to be formed into the transport layer packets, and those are going to be, that data as a whole is going to be formed up with a couple of extra bits and things like that into the internet layer for the routing and things like that, where you get your IP address tacked on to the front of that data packet, and then it gets pushed down the network. So when it gets down to the physical layer, every device that you have on the internet has a network adapter of some sort that has a physical address. And so that eventually gets stuffed onto it, and then the packet hits the wire and goes to the next hop, which for most of us is going to be our Wi-Fi router, unless we're on a cell phone, and then it might be a cell phone tower or some device at the cell phone tower, perhaps. And so the application layer is where really all of the big meat of the data happens, whether it's your web browser or an email client or something like that. That's going to be the stuff that almost is what we can understand out of all of the networking.
That's the tangible part of it.
Right.
There are other models of kind of what makes up the internet. I know there's like the TCP/IP model, and then there's the OSI model. Like, how do those two? What are the differences between them?
The real difference is with models, it's just a slightly different design of how you label what the data is in the different layers. So the OSI model actually has 7 layers, and you and I were joking before about how it's kind of like the Taco Bell 7-layer burrito. And
rest in peace.
Yeah, the physical layer would be the layer that you work on, which provides all the hardware lines and things like that. That's going to be the tortilla that wraps the burrito, and then
yay me! I make the tortilla.
You've got like the meat and the beans and the lettuce and cheese and whatever else was in the 7-layer, and you roll all that up, and as you get higher and higher into the stack of things, the stack of layers, we could look at the application layer kind of like the lettuce, tomato, and cheese inside that burrito. It's like if you could probably live without the cheese or the tomatoes. Maybe you don't like tomatoes, but you're not going to be able to live without the tortilla that is the foundation for all the layers, because they build on top of each other.
That's right. The tortilla is irreplaceable. Otherwise, your hand is full of a bunch of mush.
Right. And so the TCP layer, TCP model is just kind of a simpler perspective with just 4 layers. They kind of combine 3 layers into one from the OSI model to make the transportation layer. And there's a little bit different vocabulary in the OSI model. Generally, most people look at the internet as functioning on the TCP/IP model.
That's the one that I've always been familiar with, but maybe just because I've kind of been observing this stuff for a little bit longer, that is that old vernacular. Yeah.
So we were kind of talking about how the application layer works, and one of the big things that the application layer provides is what we call protocols. So somebody who really knows what they're talking about is probably going to nitpick that there's protocols.
Actually, Sal.
Yeah, there's protocols in the lower layers too, but the ones that we really interact with, like when you see HTTPS in a URL for a website, the HTTPS is a protocol. When you open up an email client like Outlook or Thunderbird from Mozilla, the way that those clients communicate with the servers on the internet is through a protocol. And so protocols are kind of like spoken languages for humans. So there's things like grammar and vocabulary.
What?
Yeah. But more like for computers. And instead of being, how French and Spanish and English and
they speak
Italian.
French in France.
Yeah, some people do anyway. So I've heard. But instead of all those different spoken languages kind of performing the same function, protocols are very designed, kind of optimized to be specific for a certain kind of application. So Bitcoin is an application. It lives in the application layer. It follows a protocol so that nodes can talk to each other, things like that. And
Uh,
go ahead.
I was probably just going to make a more smart ass comment than anything else because that's what I'm best at. But yeah, I was just going to say the Bitcoin protocol. You don't say, but it's kind of like we use these terminology all the time with Bitcoin, the Bitcoin protocol, the Bitcoin this, and we don't. A lot of us kind of don't understand that. Well, that is extrapolated from the greater understanding of the internet and digital communication. This was designed to be digital communication, and so of course it's not only built on the backbones of cryptography and that kind of evolution, but also on the backbone of IT and telecom. And I think that's kind of a good place to wrap up our summary of what IT and telecom is. But I think maybe you and I could riff at least for a couple more minutes about our personal suggestions of what plebs can do to kind of secure themselves a little bit better, what plebs can do to ensure that their nodes and their machines can continue to talk to the Bitcoin network in general. And my advice personally, and this is coming from just a grunt guy who's out there doing the physical construction of the Bitcoin network, and that's redundancy, as you have hit on many times throughout this conversation, is you don't have a lot of times you don't have to go with whatever's the most obvious form of communication for your machines and your nodes, and also your personal communication with other plebs, so you can do kind of peer-to-peer exchange type operations, or even purchase goods and services through them and with other plebs. So say for instance, let me break down a scenario for somebody that is that you're a miner and you're in a business park. Say that there was an empty office building, kind of like the things that Barn Miner is getting into, looking at these empty office buildings, or another guy that's on the pleb miner crew, Nico Smid, it's down in Argentina. And the ideas that they have is to let's take an old unleased business office, and it still needs heat, and it has all this spare electricity. And in that office building, you have a couple ISP providers. You have the local telephone exchange, and you have the local cable company. You can ensure that infrastructure is at least there to the premises. You might not have to have both ISPs and paying for that subscription, because of course that's going to cut into your profitability, but you can at least have that equipment on site, have the cable modem there on site if you ever need to switch. If things get hostile with the ISP, hey, we had noticed that you're transmitting, this illegal Bitcoin data, and we're gonna cut you down. Hey, guess what? Let me make a call to the cable company. They don't communicate within each other. And then somebody else in your organization can get the subscription to go back to the normal telco ISP. There's ways to be flexible and kind of a moving target. And that's kind of one of my personal suggestions, is to just kind of have that infrastructure built there for yourself so you can go back and forth. And I've always thought of this idea because I used to work in the hood and in some of the worst neighborhoods around. And this is when I used to have to go into people's houses, which was a nightmare in the hood. And you'd go in there and you'd say, okay, I'm providing service for XYZ. Oh, he's here. Okay, so you put it in there, and you'd notice, like, on the wall, here's all these other devices, all these other network devices there on the wall, because that person's account is in collections. And so, the ISP doesn't exactly come and collect that equipment that's there. So you can see these people are just flexible. They just go from one person to another that happens to be within their organization, let's say. So I think miners in particular, you can kind of do that same thing. If it gets to the they fight us stage, is that you have an option and there's ways to be flexible, and maybe somebody else within your organization can get that particular service. Sal, do you have any suggestions as to what plebs in general, small scale miners can do to stay flexible in case they get to the they fight us phase?
Yeah. So I don't know that I have some good tangible suggestions, but I look at this kind of stuff as this kind of area as kind of like what you would call threat modeling. And in IT and in cybersecurity, when we look at what we have to protect and how much should we invest in protecting what we have, one of the things you kind of have to do is go through this process of identifying, what threats are out there and how much should I spend on what I have to protect.
Mm-hmm.
That doesn't have to be a dollar amount. It could be an effort amount. It could be a dollar amount. It could be a time amount.
Right, just those different forms of capital that we all have.
Yeah. So one of the kind of tenets is that you should not spend more to protect something than that something is worth.
Mm-hmm.
And so, as a person at home, where my miner is, I don't do the dual ISP connection thing. I don't believe that the output for two ISPs is cost justified,
Right.
As a means of protecting that the mining asset. Because I just have one miner. I don't have a ton of miners. I just have one.
And you've never hit a block. Me either. Never hit one.
No. I've never actually tried solo mining.
No.
So that's something we should look into. Especially given that.
Well, the home mining wizards, everybody doing solo Sundays, right?
Yeah. And I guess that's coming off of the 3 people that hit solo blocks like in the span of like a month.
Mm-hmm.
Back
Yeah,
in
I remember
January.
that.
Yeah. But when you're getting into something a larger scale, you have some commercial investment involved. It definitely is worth the effort to assess that value and take a look at what threats there are and try to associate some amount of probability to the likelihood of those threats coming to be. Like, so fire is a very likely threat, right? And so if, as an example, so if you're mining in a facility that doesn't have a good fire system, then you may want to rethink your operations and, at least maybe it's worth buying insurance for it or new fire suppression or whatever it happens to be. That's, not my area.
But not water sprinklers. Let's X that out.
Sure. But you get the picture. It's like, we have a lot of electricity going on. Fire is certainly a high probability threat that needs to be addressed with an appropriate level of investment, given, what your size and scope of operation is.
Yeah.
And likewise, if the political and social environment gets to a point where ISP companies are starting to feel pressure to say block certain types of protocols or whatever, then, having access to be able to use multiple ISPs is certainly going to be something you want to put on your radar. Having good, reliable VPN capability is something you should put on your radar. And there's quite a few people who have done set up their home firewalls to connect to a VPN service like Mulvad or Proton VPN, or I know there's so many others, and they run their mining protocols through the VPN. I personally have not done that, not because I don't know how, or I just don't currently see that as being a threat for me. So I've chosen not to take the approach of investing a lot of.
But at least if anybody is interested, Econo Alchemist has a really good VPN mining guide. It's a really long thread and it's very well done, like most of the stuff that he does. And I believe he's got a PF Sense in there and is using Mulvad. And that's a good guy to dive into.
And I don't know him personally other than through a little bit of chat on the mining Telegram channels and his Twitter. But as a guy who's into networking, I can say that what he's got up there is perfectly good. Doing PF Sense, and I prefer a different firewall called OPN Sense because I'm a big open source guy.
Okay.
PF Sense is more of a commercial endeavor. So OPN Sense is like a fork of PF Sense that has been kept completely open, but it's very similar. And I've helped a few miners with doing stuff like this, and so that's one of the things I enjoy doing is that network level stuff. And so it's definitely something that is certainly on some people's radars. Again, for me, I don't see it as a threat that's worth a big investment right now, but it is
But
certainly
at
something
least
you
to
can
have
do.
the knowledge just in case it gets to that point.
Right. And for me, I'm kind of like maybe after I break even on my minor investment, I might take the time to try several different VPN providers and set up VPN tunnels off of my firewall to each of them and see, how they perform with mining, how they
Mm-hmm.
perform with my regular home internet usage.
Yeah, to see if your scoring hash rate drops any. I'm curious of that myself.
Yeah. And but with the, not that you're getting into another trusted third party scenario, but it's entirely possible that a VPN provider could say, hey, we really want to use this VPN for people who are doing things like using their phone, over the VPN. So we're going to just stop routing those protocols for our VPN. So you could still run into that third party security vulnerability even with a VPN provider.
Just also to mention, I do believe there was a Citadel dispatch with Catan and HODL and somebody else where they kind of went over the VPN setup. Well, Sal, I think that's definitely a good stopping point. I know we didn't cover everything, and that's kind of impossible to do because you could have a doctorate level engineering degree in IT and telecom and spend a couple years trying to educate everybody. But I hope that we communicated well enough to the plebs to give them a basic understanding of the fact that it's a very complex operation. Like you said, the largest engineering project in humanity, and it's across the globe. There's lots of moving parts. I think it's a good idea for people to kind of dive in a little bit further to understand this aspect of the Bitcoin network.
Absolutely. It's been really fun. I wanted to say thank you for inviting me. And I've been somebody who's kind of been hesitant to put myself out there. And so this has been
you're a lurker.
Yes, I am. I am a big lurker. That's like an old school term.
You're a lovable lurker, Sal. I'll give you that.
So,
well, thanks for being on, and thanks for helping out with Pleb Minor Month, and we really appreciate it.
It's been very pleasurable, and I'd be happy to come back again sometime.
Love to have you. All right, Sal. Bye.
Bye.